Okay, so today's session, we're going to continue and learn about sampling probability distribution. So everything we've learned with normal distribution, we're still going to carry that knowledge through into this session as well, including the use of the statistical table, the calculation of the Z-score for standardizing the normal distribution. But we're going to introduce some of the new concepts that relates to the sampling probability distribution. By the end of the session today, you should learn the basic concepts of sampling distribution. You should learn how to find the probabilities of a sampling distribution using the formula as well as the table to go find the probabilities on the table. And the same rules still applies. When we find the probability of a Z value lower than a certain value, then we're going to find that probability on the table. When you find the probability of a Z value greater than a value, then you're going to say 1 minus the value you find on the table. And for between, you're going to subtract the table value of the bigger number from the table value of the smaller number. We're going to take that through the session as well. So it's everything you have learned in the previous session. What is sampling distribution? A sampling distribution is a distribution of all possible values of a sample statistics for a given sample size selected from a population. What we mean, we have been talking about the population. So when you have one population and from that population, you take a sample, which is a subset of that population. And you do that not only once, you do it multiple times. You go back to that population and you select another sample and another sample and another sample. That is what sampling distribution is all about. It's us making sure that all those samples, we standardize them and transform them into a normal distribution. Because when we select from those samples, sometimes those sample and the population that we're selecting from is not normally distributed. Therefore, we need to make sure that we are able to standardize those samples in order for us to have a normally distributed samples. And that's what we're going to be doing. So the process of sampling distribution is taking all the averages from all the samples and transforming them into a normal distribution. So from a population, let's assume that we have one population. We select the age of those population and we calculate the population parameter, which is the mean. And we can also calculate the sample, the population standard deviation, which is also another parameter. So if these are our ages from that same population of the 4 people, they are 18 years, 20, 22, and 24 years from that population that we selected. We are able to look at the distribution of that population. And when you look at that distribution, you will notice that it's only 1, 1, 1, 1, 1. So probably the distribution will be 2.5, 2.5, 2.5 probability distribution of that. And that distribution, as you look at it here on the picture, it is a uniform distribution. So it's not normally distributed. So we need to transform this uniform distribution into a normal distribution. We can calculate the mean of this population. We know that the mean is 21. The standard deviation of that population is 2.236. If we want to do, if we want to convert or transform this into a normal distribution, then we have to go back and resample from the same population. Depending on how we're sampling it, maybe we might select 18, 20, 20, 18 again, but we need to resample. So let's say we go back and resample again twice. from the same population. So we go and select the first group of 4 people, and then we go back again and we select group of 4 people. So we are sampling it twice. And we can calculate the mean of all those. So these are the possible sampling outcomes that we have if we do this without replacement. Oh, sorry, with replacement. So you will notice that you will have your first time that you sample and the second time that you sample, and you have your sampling, possible sample measures that you have, or values that you will have. Then we take from those, we can calculate what we call the sample means. We calculate the means of all each sample means, because we said we wanted to create 2 samples of each, so we created those. So the mean, if we selected 2 18-year-olds, then the average of those will be 18. If we selected an 18 and a 20-year-old, the average will be 19. If we selected an 18-year-old and a 22-year-old, then the average age will be 20. And if we take this sample means and we plot them, you will see that they take a shape of a normal distribution. Therefore, by processing the same sample, the same values that comes from the same population, but applying the sample process, the sampling process of a sampling distribution, we are able to convert a uniform distribution into a normal distribution. Okay, so there are some characteristics of a sampling distribution. So some of the measures that you can get from a sampling distribution. So because it's a sampled mean, so we need to calculate the mean of a sampling distribution. So we did already do calculate or do create the sample mean. So if we take all these values and calculate the mean of this sampling distribution, then that will give us 21, because we're going to add all the sample means, divide by how many there are. There were 16 possible sample means or samples that we can create. So we take the sample means, divide them by how many the possible outcomes can be, and we get the mean of a sampling distribution to be 21. And to calculate the standard deviation of a sampling distribution, we take the mean and the outcome of a sample means, or the average of the sample means, subtract from one another squared, and we add all of them and divide by our sample mean. Oh, sorry, our sampled outcomes, which there were 16, and we find that the standard deviation of a sampling distribution of the means is 1.58. Now, if you remember, we calculated from the population, the mean was 21, the standard deviation was 2.236. So in a way, what we're saying as well is that the mean of the population and the sample mean of sampling distribution, they are the same, but the population standard deviation are not the same. So our population, we had the mean of 21, the standard deviation of 2.3. The sample mean distribution with two possible two sample sizes, we get the mean of a sample mean distribution to be 21, the population standard deviation to be 1.58. We can conclude by saying we transformed a uniform distribution into a normal distribution by applying the sampling distribution process. So we spoke about the standard deviation of the sampling distribution. The other word for saying the standard deviation of the sampling distribution, it is also called the standard error. So a standard error is it's a measure that is collected from different sample of from the same population, and when we calculate the standard deviation of those, it yields a different measure. Like the variation of those samples becomes different from each sample. So they will be different based on each sample that you would have created as well. And the standard error is also a measure of variability. In a way, it also a measure that you use to calculate dispersion, right? How far apart your values are from the mean. And here we're talking about the sampled mean. And remember, the standard error, it is also called the standard deviation of the sampling distribution of the mean. And to calculate it, we use this formula, sigma x bar, which is the standard deviation of the sampled means, because we are sampling the means. So it's the standard deviation of the sampled means. It's given by the population standard deviation divided by the square root of n. And that will give you your standard error or the standard deviation of the sampling distribution, or it will give you the standard deviation of the sampled mean. I know it's a long way to say. Okay. Please note that the standard error of the mean decreases as the sample size increases. So the bigger your sample size becomes, your standard error decreases, the value of the standard error decreases. So if you have the population of, the sample of 100 and you have the sample of 50, so a sample of 100 will have a 1.3 standard deviation or standard error, and a sample of 50 will have a 2.3. That is what it says here. The bigger the sample size, the smaller the standard error. The smaller the sample size, the bigger the standard error. Okay, we're gonna discuss that a little bit further based on the central limit theorems as well. So what I just explained is, as your n increases, your standard error decreases. So if you look at the two graphs here, the red and the orange. So the red has a small sample size, and the orange is a normal distribution where you have a large sample size. As you can see that the distribution of the two are different. So the larger the sample size, the standard error or the deviation away from the mean is always smaller, and the smaller your sample size, the distance or the distribution or the variation between your mean and your observations are bigger. Okay, so based on the central limit theorem, as your sample size increases as well, your distribution also tends to become normally distributed. And that is the central limit theorem. If you look at this distribution at the top, you can see that it is skewed. And when we increase the sample size, you will see when we increase the sample size, that right skewed data becomes now normally distributed. And that is the property also of a central limit theorem based on the sampling distribution. So now, if I have a normal population or if my population is normally distributed with the mean and the standard deviation for the sampling distribution, we can always assume that that population is distributed with the sampling distribution of the mean being equals to, or the same sampling distribution of the mean will be the same as your population mean, and your standard error will be your population standard deviation divided by the standard deviation. And this is if and only if your population is normally distributed. So let's look at an example of how we can apply those properties in calculating the mean and the standard deviation. Suppose a population has the mean of 8 and the standard deviation of 3. Suppose a random sample of n is equals to 36 is selected. Calculate the mean of a sampling distribution. We know that the mean of a sample distribution is equals to the mean. Therefore, it means the answer there will be equals to 8. The standard deviation of a sampling distribution, we know that the standard deviation of a sampling distribution is given by the population standard deviation divided by the square root of n. Our population standard deviation is 3 divided by the square root of n of 36, which is 3 divided by the square root of 36 is 6. Therefore, it will be 1/2, or it is equals to 0.5. And that's how you will answer question if they ask you to find the mean or the standard deviation of a sampling distribution. And if they don't ask you to find the standard deviation of a sampling distribution, they might ask you to find the standard error. You must know that it's one and the same thing. Okay, so for us to standardize your sampling distribution values or the sampled means, we need to use the Z-score formula. And the Z-score for standardizing this sampling distribution is given by your population, your sample means minus your population mean divided by the standard error, which is the population standard deviation divided by the square root of n. And once you have calculated the Z-score, then you need to go to the table to go find the probability if they're asking you to calculate the probability. And the same rule still applies. If you are going to find the probability of a less than, is the value you find on the table. And remember always, the table contains all the probabilities of a less than, regardless of whether it's the negative side of a table or the positive side, side of a table. If you're going to calculate the probability of a greater than, then it's 1 minus the value you find on the table. If you're going to do the between, it is the bigger one minus the smaller one from the table. Okay. Remember also the table has two sides. Both sides contains the smaller than values. And if you aren't sure about that, you can look at the graphs there. They tell you that the values in this table are those that are cumulative values of a less than. So the negative side and the positive side of the table. Let's look at an example. Suppose a population has the mean of 8 and the standard deviation of 3. And suppose a random sample size of n is equals to 36. What is the probability that the sample mean is between? Therefore, here they're asking us to calculate the between. And in order for us to calculate the between, we can standardize the probability or the sample mean by using the Z-score formula. So we're going to first start with the 78 on the less than. So it's 7.8 minus our mean of 8, divide by the standard error, which is the standard deviation of 3, divide by the square root of 36. And on the 8.2, we say 8.2 minus 8 divide by the standard error of 3 divided by the square root of 36. And then we get the answer. When we solve this equation on the left, we get minus 0.4. And when we solve on the right, we get 0.4. Now, from here, we need to go and find the probability of Z less than 0.4, and we're going to find the probability of Z less than minus 0.4. So we first going to find the probability of B, and then go find the probability of A. And when we go to the table, and we find that Z of 0.40, it's 0.6554, and for Z of minus 0.40, it's 0.3446. And we do the difference, and we find the answer of 0.3108. And that's how you will find the probability using the same table. I'm gonna show you the table later on as well. So not only do we do sampling distribution for the mean, but we also do the sampling distribution for the proportion, which is another term that we are now introducing into the mix. So for the proportion, it is denoted by the pi. And the pi represent the population proportion, and that they will give it to you. From there, you will need to calculate the probabilities and all that, but they need to also give you the sample proportion. And if they don't give you the sample proportion, then you can calculate the sample proportion, because they will give you observations satisfying that sample proportion and the sample size. And you are able to calculate x divided by n, where x is your number of items in the sample having the same characteristics of that interest, or the number satisfying that sample. So they will give you the outcomes, which are your x value, and you can then take your sample size and calculate your proportion. And always remember that, because we're talking about proportion, your sampling proportion and your population proportion can never be bigger than 1, and they can never be lower than 0. So always your proportions lies between the value of 0 and 1. Same as previously with the means, your sample proportion is approximately distributed as normal distribution when your sample size is larger. So the more your sample size becomes larger, the more your sample draws towards being normally distributed, or the more your sample becomes more normally distributed. And we can do these assumptions with replacement or without the replacement when you are doing your samples, when you are selecting those samples. So with sampling distribution for the proportion is still the same. So what we're trying to do with the sampling distribution is to take your population and transform that into being normally distributed, and that is only applicable when your sample size times your population proportion is bigger than or equals to 5, as well as your sample size times 1 minus your population proportion should also be bigger than 5. And for us, and for you to also understand that for a sampling distribution to be normally distributed, it is normally distributed with the mean or the expected value being equals to the proportion, as well as your standard error of the proportion. So now you must notice this. When we were talking about the mean, we said the sampling distribution of the mean or the standard error of the mean. Here we're talking about the standard error of the proportion, and hence we put the P. It will be given by the square root of your population proportion times 1 minus the population proportion divided by n. Sometimes they might not give you the population proportion, but you can still calculate the standard error using your sample proportion. And later on, when we look at the confidence intervals, we are still going to use this, but the equation changes from the population proportion to sampling proportion. But that is the standard error, or what we call the standard deviation of the sampling distribution of the proportion. Let's look at the next example or an exercise. From past knowledge, Africa knows that the true proportion of ghost profiles on Facebook is 0.2. So they told us our population proportion. Suppose we take a sample size of 200 Facebook profiles and only found that 34 to be ghost profile. So that is our N and that is our X, because they give us observation satisfying that sample, which enable us to go and calculate our sample proportion. What is the value of your population proportion and what is the value of your sample proportion? So we know that our mean, our sample proportion, it's the same as your mean is the same as 0.2. Our standard error or sampling, sorry, not sampling proportion, not standard error, our sample proportion is given by the observation satisfying divided by the standard, the sample size. So the observation is 34 divided by 200. And then you need to go and find your calculators and calculate the answer. $34 divided by 200. 0.1. And the answer would be option number 4. And that's how you will answer the questions as you get them. Okay. So in order for us to calculate the probability, we need to first standardize our sample proportion by using the Z value. And the Z value for standardizing the sampling distribution is your sample proportion minus the population proportion divided by the standard error, which is the square root of your population proportion, 1 minus the population proportion divided by n. Let's look at an example. If the population proportion is 0.4 and n is equal to 200, what is the probability that your sample proportion lies between two values? Same, we need to standardize this P by using the Z-score formula. And we do that, and but before we do that, because the standard error, the value at the bottom, is complex as well, we can go and calculate it first. If you are using a Casio calculator, you don't have to go and calculate it first. You can just substitute your values onto your fraction calculator and it will do the calculations. If you are using other calculator that do not have the fraction button, then you will need to calculate your standard error first and then substitute the values into the formula. And our P is 0.04. Our population proportion is 0.04. And our standard error, we calculated the whole thing and we substitute the value. Our P is 0.045. Our population proportion is 0.04 divided by the standard error, which is 0.03464. And then we go and find the answer. When we solve this side, 0.4 minus 0.4 gives us 0.00, and 0.45 minus 0.4 gives us 1, or divide by 0.3464 gives us 1.44. We go to the table, we go find the probability that Z is equals to 1.44 on the positive side of the table. Remember, you will go where it says 1.4 and where it says 0.04 at the top, where they meet. That will be the probability that we are looking for. You go and find that probability on the table, and you go and find the probability of Z equals to 0.00, which is 0.5. So 1.44 Z value corresponds to probability of 0.9251, and the Z of 0.00 corresponds to 0.5, and you find the probability is equals to 0.4251. And that's how you will find the probabilities on the table. I'm done. Are there any questions? Any questions?
Lizzie, the more we do this, the more I'm scared for the year-end final. I'm like, am I gonna remember all of these things?
You're gonna remember all of these things because you're gonna practice and you're gonna watch the recordings and all those things. And by the time you get to the assignment, you would have at least have known something. By the time you go to the exam, you would have mastered it from the assignments.
Hope so.
Yep. Okay, so let's look at activities. Do the activities. I'm going to switch screen sharing to my entire screen. Okay, so let's get to the activities. The diameter of a brand ping pong machine is approximately normally distributed with a mean of 1.3 inches and a standard deviation of 0.08 inch. If a random sample of 4 ping pong machines or balls is selected, the mean and the standard deviation of the sampling distribution of the mean are respectively. So first we go and we find out what we are given. We are told the mean is that. We are told the standard deviation is that. We are told our sample size. I'm going to write it in numbers. It's 4. And they're asking you to find the mean and the standard deviation of a sampling distribution of the mean. So the first thing you need to know is what is the mean of a sampling distribution of the mean? It is the same as the population mean. And what is the answer?
1.31.
1.31. And the standard deviation of a sampling distribution of the mean is given by the population standard deviation divided by n. So what is our population standard deviation? You said it, 0.8 divided by the square root of 4. And what is the answer? Take out your calculators and calculate and tell me the answer. The square root of 4 is 2. So 0.08 divided by 2. Nobody.
0.04.
Divide by 2 is 0.04. 0.04, which is option D. Moving on to exercise 2. The diameter of a brand of a ping pong ball, which is almost the same information that we had previously. We know the mean is 1.31. The standard deviation is 0.08. The standard error, I'm going to put it here as well. Calculated it previously. The standard error is 0.04, or you don't have to calculate it. What is the probability that the sample mean is less than? What does less than mean? Is this the less than, or is this the first or the second? How do we represent the less than? We represent it with the first one, right? You need to remember all the signs as well. Don't forget, remember that. 1.28. Therefore, we need to find the probability that Z is less than. If I write the formula, will be the sample mean minus the population mean divided by the standard error, which then means I'm going to find the probability that Z is less than. Our sample mean is always in the question. It's 1.28 minus your population mean. It's given in the statement, 1.31 divided by the standard error. I can go and calculate again, or I can just use the standard error from the previous question we calculated. And therefore, our probability that Z is less than, in my calculator and calculate. As you can see, I'm using a very old calculator. Let's go to the scientific. This one, scientific. Okay. So we have 1.28 minus 1.31 equals, and I get the answer, which is minus 0.03 divided by 0.04, which gives me minus 0.75. Minus 0.75, because this is the probability of a less than. They said if I need to find the probability that Z is less than a value, then I will find that on the table, right? That's all what we remember. So now let's go to the negative side of the table and look for minus 0.75. So we go 0.75 7. And then we go to the top and look for the last digit 5, where they both meet. Which is, make it bigger, which is 0.2266. Which is option number 1. Easy, né? There any questions? You are so quiet.
I'm good, thanks.
Okay. Now we have the proportions. In a random sample of 100 people, 25 are classified as meeting a characteristic of interest that is success. Suppose the proportion of success is known to be 0.3. So we are told the sample size, we are given our X, we are given our population proportion. You need to be able to identify the things given to you or the facts given to you in the question or in the statement. What is the sample proportion? What is our X?
25.
And what is
divided by
our
100.
divided by 100? And what is 25 divided by 100?
0.25.
What is the standard error? So we just substitute into the formula, which is 0.3 times 1 minus 0.3 divide by 100. I'm gonna use my 1 minus 0.3, it is 0.7. Multiply that with 0.3, which we multiply with the value side, which is 0.21, and divide the answer by 100 equals 0.02.
We divided by 10.
Did I
Yes.
divide by 10?
Mhm.
Okay, let's start again. 0.3 times 1 minus 0.3, close bracket, equals divided by 100. It is 0.0021. And then we take the square root of that answer. I'm gonna take the square root. I'm not sure if my calculator works. And the answer is 0.458. I'm gonna keep it to 4 decimals because they've kept most of the answers to 4 decimal, which is 0.0458. So my answer here will be 0.0458. So I'm looking for 0.25 and 0.458, which is option 4. Moving on to exercise 4. A random selection of 64 households was selected for a telephone survey. The key to ask was, do you or any member of your household own a cellular telephone that you can use to access the internet? Of the 64 responded, 32 said yes and 32 said no. The population proportion is 0.75. So the population sample proportion, I don't know what they mean by that, because it cannot be the population sample proportion. It has to be the population proportion, which is the pi. And we are given our sample size, and we've got 2x observations, the n, the yes and the no. I'm just gonna leave them as such, and we're gonna either one. If they ask you what is the sample proportion of those who answered yes, you're gonna use the yes as your x. If they say those who answered no, you're gonna use x as no. Okay, so the following, which one of the following statement is incorrect? We're looking for the incorrect one, so it means we need to validate each one of them. The first one says the sample proportion. Either one we can choose because they didn't, the yes and the no are both the same. So we can just say the sample proportion, it's given by x divided by n. There are 32 divided by 64. And the answer is 0, So on here, if they would have said, what is the sample proportion of yes, you would use the yes. If they would have said, what is the sample proportion of the no, you'd use the no. Because they are both 32, so probably that's the reason why they didn't ask you in that sense. We can select one of them as a sample proportion. So this is correct. We're looking for the incorrect one. The standard error of the proportion is that. The standard error of a proportion is this. So we've got now option 2 and option 3 asking us the same thing. So let's go and see. The standard error of the proportion, remember, is the population proportion 1 minus the population proportion divided by n. So if you substitute the values, your population proportion was 0.75 times 1 minus 0.75 divided by our sample size of 64. So go and calculate. So 0.75 times 1 minus 0.1 minus 0.75 is equals to 0.18. Divide the answer by 64 equals 0.002929. Take the square root of the answer and we get 0.0541. So the answer that is correct is this one. This one is incorrect. And here it says the sample proportion is 1/2, which is correct because 32 goes 1 time into 32 and it goes 2 times into 64. And the next one says the probability that the proportion is less than 0.065 is this. So we can go and test that. because we need to calculate our Z, which is P minus the sample proportion, the population proportion, divide by the standard error, which we calculated. I'm not going to write the entire formula. Our P, we said it's 0,5 minus our population proportion of 0,75 divide by the standard error. We said it is 0,0541. And calculate that. And because I'm rounding off too quickly, I must be mindful of that. So 0.5 minus 0.75 equals divide by 0.0541. And I have the answer as minus 4.62. Minus. So we go to the negative side and look for minus 4. And I don't find that on here. Did I calculate the right? Sorry. Let me use my calculator. Okay, so we have 0.5 minus 0.75 divide by the square root of, I'm going to just calculate the entire thing, 0.75 times 1 minus 0.75 divide by 64. Yes, I get the same. It is minus I used 0.5. Guys, you don't say. We need to use 6.5, not 0.5. We are given 65. Oh, sorry, my bad. You need to read the question correctly. So this should be 0.65. One little mistake can throw you out totally, which is minus 1.85. It's 0.65 minus 0.75 equals divide by 0.0541 equals. Because we need to keep only 2 decimals, so it's minus 1.85. So minus 1.8 and 5 will be the last one at the top. Minus 1.85 and the answer is 0,0322, which is correct. And that's how you answer the question. And that concludes our session for today, but I do have more activities that you can look at. You can take a screenshot of the next 2 questions, 3 questions. So this is the first one. You can do on your own and share on WhatsApp if you want us to help you. That's the other question. And the last question of the day. And likewise,
Lizzie, can I have question 6, please? Sorry. Thank you.
Okay. Get question 7.
I do. I got 7. Thank you.
Okay. Likewise, thank you for attending the session. We appreciate it. We from Pambili Analytics, where we're trying to bridge the gap in terms of data literacy and analytical skills. And we do this by offering a range of services, including one of our flagship program. We no longer have a special, so we're back to 350 per hour. You can book your session if you need assistance. Thank you to those who have already subscribed to our channel. Please remember, subscribing is for free. You can subscribe, like our videos, put a notification cap in case you want to receive notification when we send new recordings. We also appreciate those who join the channel as members. Your contribution is appreciated. And I want to give a shout out to Peter, Johannet, Koji, and Knox for your support. Not forgetting the others who are also supporting the channel by being cheerleaders and supporters. And we really appreciate you as well. You can get hold of us via email or WhatsApp. Otherwise, you can find us on social media. And thank you for coming. Have a lovely weekend.
Thank you. You forgot to put on your LinkedIn page, Lizzie.
I will add that. Thank you.
Bye. Have a good weekend.
Bye.